Hey y'all, I wanted to take a minute and talk about max slope in a zone with grading optimization for Civil 3D. So I've been working with this product for the last year and a half since it came out with 2022, 2023 grading optimization for the AEC collection, and I came across this really great abstract example for zones, max slopes, and how it works. So, and I want to illustrate that, and we're gonna take a look at an abstract project here and understand how those zones work independently with that max slope. So today's agenda, we're going to go over zones, interaction with max slope with grading optimization, create those zones in Civil 3D, kick that out to grading optimization. Second thing, we're going to create a profile view of the surfaces and look at how the different surfaces, the shape of them based on the constraints of different zones. So let's go ahead and bounce into Civil 3D here. And this did take a minute to set up, so I'm going to show more of an overview of what was done and an overview of what was done versus the step-by-step on how to do each component. So Civil 3D, we're in 2023, and this is our EG surface right here. And fairly large surface, and what I did is you can see there's a few different grading objects here. We have our grading limit, which is this exterior rectangle square, and you can see there's no slope constraint set. So that means the slope can be whatever it wants within the confines of the grading limit. Now, within the grading limit, I defined 4 zones. So, and they're all on top of each other, just squares on top of each other. So zone 33 has a max slope of 33%. So 33%. There's no drain slope set because we don't care about the drainage. We just want to see what the max slope does. So let's go ahead and close this, and we can just open up 15, for example, and you see 15, same spot. 15, name, 15% is the max slope. And then the other twos is we have a 10 and we have a 5. So we're going to watch what happens with a decreasing max slope for the same zone in the same spot. So if you look at this surface a little bit before we jump into grading optimization, you can see there's some pretty, just making a few spot elevations, you can see there's some pretty steep slopes. For example, 26% right here, 25% right here, 16%. We're at 10%, 11%. So we're going to see some variation. So maybe the 33% we'll probably see less adjustments to the surface versus the 5%. So jumping into grading optimization, we'll just run one of them quickly. And what I did is we have the same 4 zones right here, and I ran each one independently. So for example, if let's run the broadest one at 33%. So turn this button, slide it to the right, on, and we'll make it visible because it's active. So everything else is non-visible, and we'll just hit optimize. So you can see there's not a whole lot of changes. We can see we have our max slope violations displayed. There's no max slope violations. That means it's solved everything. And you can see we're trending toward a solution. And if I get my mug out of the way, you can see that we're at point with a bunch of zeros. So that means we are the closer it is to 0, the closer you are to a 100% solution. So we are very, very, very close. So, and then if we say stop here, so just take a mental image of what this surface looks like. You can see there hasn't been too many adjustments to it because the max slope is 33%. Now let's go ahead and restart this, and let's knock out the 33%. Let's go to 5. So we said 5, make it visible, and you can see this is our 5%, right here. We see 5%, our max slope. So let's go ahead and optimize this. So you can see that there's a lot more changes to this surface because we have a 5% max slope we need to meet. You can see there's probably going to be some steeper slopes on the outside here. We have a 21% slope to get up to that 5%. So you can see we're in the same realm of a very low number, very close to 0, where the optimizer is very confident in the solution. And we're seeing we don't have any violations. So the way it means is we have no violations, that means everything should be under 5%. So let's stop this and let's bounce back into Civil 3D. So what I did is I made a bit of an interesting alignment. I'm kind of like a snake. So I made an alignment and it's snaking up like this right here. And up she goes and up and up. And what we want to see is we want to see the slopes we want to create an alignment. We want to create a profile view with all those surfaces in it and see the slopes within each. So I created a profile view right here, and we have 5 surfaces within it. The EG, the 5, the 10, the 15, and the 33. And you can see the colors here. So e.g. that red down here, 5% this yellow, magenta 10 right here, 15 at this blue line, and then 33 with that cyan color. So what we're looking for is we're just trying to, this helped me understand a lot of seeing that, all right, so a 5% max slope, we're going to look at all these slope labels. You can see that there's been more changes to the surface because it needed to, it can't have the slope be over 5%. And you can see we're at 3%, 3.5, 3.5, 3.5, and then you see 3.5, 3.5. And so you can see we're fairly consistent. We're all under 5% with that yellow profile. So moving into the magenta one, that's the max slope of 10%. So we should be seeing bigger changes with that surface because we gave it more freedom. So you can see we started out, we're at 7, 6, 4, 8, 4, 4, 4, 6, 7. But you can see we have a 7 here, but we had a max of 5 with the yellow. So this gives it that more freedom while we're seeing the 7 here. 7 and whatnot. But we never saw it go above 10. So that blue line, 15%. Oh, yeah, that blue line, 15%. So we might see a few in the 10 to 15 range here. And let's take a look. So a little bit, we got a couple of lines on top of each other, but this is the blue profile right here, the labels. So we're at 12 now because we gave it a max slope of 15. So we're at 12, we're at 11, 9, 8. And we kind of keep going across. We can see if there's any exceed 10 now. And then going towards that cyan line, that last one, the max slope of 33%, you can see we might have something over 15. And let's see, we're at 14.62, so we're close, but it doesn't look like we exceed 15 for this surface. And any other spots, I'm not seeing any. But we did give it the freedom that if the surface was, if it was jagged enough, it would have gone into that, we would have seen a 33, 15 to 33% region. And then last thing, the EG surface, you can just see that, there's some pretty broad slope changes to it. And, it's fairly jagged, but you can see that the optimizer is definitely changing that surface based on the constraints we give it. So I found this to be really helpful to see how the zones interact with max slope, trying to understand, if I set a 5% max slope, what's that going to do? And, you can do this with a quick profile view too. Just throw a quick profile view in. You don't even need an alignment, and just see what it looks like. So it just gives you an idea that the more constraints you give it, the more that surface is going to have to meet it. So that yellow line with a 5% max slope is going to be, you're going to see a lot flatter of a surface than if you gave it a max slope of 33% or 15% and whatnot. So I want to thank you for your time, and good luck with grading optimization and implementing this with your designs.